Here's the answer to question 2c. So factorise the following expression. Okay, this is a special case of something called difference of two squares. And I've seen enough of these to recognise the pattern. And so let me just explain what the pattern is by giving you a different example, and then we'll go back to this. Say I had this x plus 2 in brackets and x minus 2 in brackets. And if you look at those brackets, they're absolutely identical except for the fact that one has a plus in it and the other has a minus in it. Everything else is exactly the same. Let's try expanding that out. So x times x will give me x squared. X times minus 2 will give me minus 2x. 2 times x will give me plus 2x. 2 times minus 2 will give me minus 4. Simplifying that, x squared is fine. The minus 2x plus 2x, they cancel each other out. So then I'm just left with x squared take away 4. So what I notice when I do this is the difference of two squares, though, that middle term, that x term, always disappears. And the number by itself is itself a square, because that's just 2 times 2. And x squared is itself a square, x times x. And so that is a pattern that I've learnt to recognise. So I'm going to do the same thing with this one here. If I take 25, just take the number, the square root of 25 is 5, square root of a squared is a. Then take the 64, square root of 64 is 8, and the square root of b squared is b. Alright, because then I know 5a times 5a will give me 25a squared, and 8b times 8b will give me 64b squared. And because there's a minus in between it, it means I've got a difference of two squares. So both of the brackets are exactly the same. One has a plus, one has a minus. Put the equals in there, and there's our answer.